Good morning, folks. Good afternoon, depending on when you're working on this module here. Um, Today we're going to work on direct, joint, and inverse variation. Also, just a reminder, please do fill out that quiz there for the attendance purposes. That'll go in as a 1 point assignment in PowerSchool. Of course, click yes that you've worked on the DLD module. You'll get your point, and you'll be counted uh, as attendance. Okay. There will also be a regular homework assignment attached to this. That'll be 5 points in PowerSchool. Um, we'll have 6 or so questions here at the end of this notes and lesson here, where we go through and we work a few of these on our own. So that's kind of the game plan here for the DLD day. Here, this is for the 26th of October again. So Thursday, and then we'll have one for Friday tomorrow as well. Which will need to come in at 8 o'clock. All right, so again, 8.5, direct, joint, and inverse variation. Here we've got a little example of why we have these variations. Um, it really just relates that there is while building skateboards ramps, okay, this guy determines that best ramps were ones in which the length of the top of the ramp was 1.5 times as long as the height, 1.5 times as long as the height. So length equals 1.5 height. These are the best ramps, okay? These here are the best ramps. And this table shows that relationship, okay? So if the length was 3, the height was 2. That kept the 1.5 ratio, okay? All of these here keep the 1.5 ratio, the length over height, okay? So what 1.5 is, 1.5 is called a constant of variation, okay? It remains constant. We see it here in each one, right? It's that length over height equals 1.5. Okay, on any of these combinations, length over height equals 1.5. Um, and that's what we call a constant of a variation, okay? And you can get that by solving this equation here. If you divided both sides of this equation by h, you would get length over height equals 1.5, okay? So these are both, they're connected somehow, okay? And exploring that connection is going to be what this lesson really takes us through, okay? This example here is a example of direct variation. Length varies directly with height, okay? So let's continue down then here. Um, in general, okay, we can read through this paragraph if we'd like, but in general, a direct variation, here where a direct variation can be expressed in the form y equals k times x, okay? In this equation, k is called the constant of variation. So if we revisit the example up top here, uh, the constant here, the 1.5 that we saw, 1.5 is our, in this example, constant of variation. Okay? And you can see that that 1.5, these next couple of paragraphs here, go on to discuss that. Length equals 1.5 height is a straight line through the origin. This is a direct variation. A direct variation. Right, and it relates it to special cases, but again, it's just related to y equals kx here. So the key concept here, talking about direct variation. Ooh, yeah. Stay on this technology. All right, so the key concept here, direct variation. Y varies directly as x if there is some non-zero constant k such that y equals kx. So our direct variation, y equals kx, okay, where we have a constant of variation. Let's revisit real quick. I know we keep going back to it, but it's useful. Let's revisit this first example. Let's revisit this first example here. Okay, each of these, the table, okay, each of these. 3 over 2 equals 1.5, equals the constant. 6 over 4 equals 1.5, the constant. Okay. 9 over 6 equals 1.5, the constant. All right. What I'm trying to get at here, guys, is when we have a direct variation, pairs work together. Okay. What we had in this example was related right here. We had that length one to relate all of this here to our example. Okay. We had that length one equals the constant 1.5 times height 1. You divided that by height 1. You got that length 1 over height 1 equals the constant, which was 1.5. Okay, so 1.5 is the constant. Okay. Okay. You also had that length 2 with our 6 over 4. We had that length 2 times the constant 1.5 was equal to height 2. Divide this by height 2, and you had L2 over H2 equal the constant. 1.5. 6 over 4 was 1.5. So what this gets at is this all implies that length 1 over height 1 must equal length 2 over height 2. Okay? And this is a general statement of that exact idea. Okay? And we're going to use this type of proportion we see here, y1 over x1 equals y2 over x2, to solve for various unknowns throughout this lesson. Okay, so let's take a look at the first example we have. If y varies directly as x, well, that first bit gives me that y is equal to some constant times x. That's a direct variation. Okay. All right, and y equals 15 when x equals negative 5. That gives me a pair. That gives me a y1 equals 15 when x1 is negative 5. Okay. Well, we want to find y when x, our second y value, when our second x value is 7. So again, using this gives us that y over x is equal to k. Y divided by x is equal to the constant. Well, thus, y1 over x1 must be equal to the constant. Okay. Y2 over x2 must be equal to the constant. So these must be equal. We can set up an equation now. Let's do it. Let's substitute in our values. Y1 we said was 15 over x1 negative 5 equals y2 is what we are looking for over x2 is 7. Solve this equation. 15 over negative 5 simplifies nicely. We could also cross multiply and divide, but no need on this one. Multiply both sides by 7. And we get that negative 21 is equal to y2. Okay, we found y when x was equal to 7. All right, let's take a look. Next example. Actually, you guys go ahead and pause. Try this guided practice problem on your own. All right, try this guided practice on your own. All right, if you're coming back to us, let's take a look at it together. R varies directly as t. That gives me that R is equal to t times some constant of variation. This, of course, gives us that R divided by t equals the constant. Okay. Then we have that R1 would be negative 20, while T1 is equal to 4. Okay. This is my first relationship that I have. Relating R and T. My second relationship that I have, well, I'm looking for the R value when T is negative 6. So I should have set up a proportion here. Negative 20 over 4 equals 2 over negative 6. We want to cross multiply and divide. We'll solve the other one that way as well. Negative 20 times negative 6 is 120 equals 4 times R2. Divide both sides by 4. And go for 30 equals R2. All right. So these are two examples of direct variation. We'll have a couple of these here on our homework, so you can refer back to these two examples. Um, let's continue with joint variation. Joint variation very similar to direct variation. However, y, let's just take a look here at the key concept. Y varies jointly as x and z if there is some non-zero constant k such that y equals k times x times z. This is just adding another variable here. Okay. If we look at this equation, y equals k x z, we can see that solving for k, there's another proportion that we can use. Okay. We'll be able to set up proportions, and we just go through the same process we did with direct variation. Okay, we get that, we can start getting some pairs here. Y1, x1, z1 equals y2, x2, z2. We see that here. Okay, so we're going to set up groups of numbers. It's the same type of problem. We're just setting up groups of numbers here. Okay. Let's use the course there with the board. Suppose y varies jointly as x and z. Well, a joint variation, we can represent that as y equals k times x times z. Of course, that gives us that k equals y over x z. And we're just using this exactly what we saw. Okay, we're creating groups of numbers. So we want to find y when x is 9, z is 2. If y2 was 20, we're grouping these next three terms here. y2, x2 is 5, z2 is 3. That's z1 over here. And we're just using that proportion again. So y1 over x1 is 9 times z1, 2 equals y2 is 20 over x2 times z2. Okay, simplifying this, y1 over 18 equals 20 over 15, which would simplify to 4 over 3. Press multiply and divide. Y1 times 3 is 3. Y1 equals 4 times 18 is 72. Divide both sides by 3, you get the Y1 is equal to 24. Okay, go ahead, pause, try this next example here on your own. You should get the R1 is equal to 28. Go ahead, pause, try that. See if we can't come up with that proportion. Okay. Welcome back with us here. Again, we have a joint variation, so we set up the equation. R equals, very jointly as b and t, so k times b times t. This gives us r over bt, k equals r over bt. The groups of numbers, we got r1, b1, t1. Is what we're looking for. b1 is known, t1 is known. Second group of numbers here, RVT, so R2 is 70, B2 is 10, T2 is 4. All right, now we use this R over VT idea to set up our proportions. R1, 8 times 2 equals R2 is 70 over 4 times 10. All right, simplifying this, guys, we get the R1 times 40, 40 R1. 4 times 10 is 40 times R1, so 40 R1 equals 16 times 70. Calculators here. Yours as well. Use your cell phone. Your 16 times 70, 1120. Divide both sides by 40 here. You put R1. As we figured here. R1 equals 28. Awesome. Alright, let's continue. Look at inverse variation, guys. Inverse variation is the same type of problems, guys. We're going to be looking for unknowns, somehow relating a constant to some unknowns. So, inverse variation, y varies inversely as x if there's some non-zero constant k, such that x times y equals k. Now we have a product equals the constant. Okay, so as you may figure, we're going to be able to set up x1 times y1 equals x2 times y2. This is an inverse variation. Right, so let's continue. Let's do one example here together, and I'll let you guys have that the last one here. So a varies inversely as b. Well, that tells me that a times b, an inverse variation, a times b equals the constant. A times b equals the constant. Well, now grouping numbers. Okay, a is 28 when b is -2, so my first group, a1 equals 28, b1 equals -2. We're looking for a2. We're trying to find a, and b2 is -10. A times b equals the constant. Well, that tells me that a1 times b1 must be equal to b a2 times b2. So -56 equals -10 a2. Divide both sides by -10. 5.6 a2. Go ahead and try the last example on your own. Very similar problem. All right, we should get that x is equal to 8. So thanks for watching. Do the quiz. Finish the homework. Those will both be PowerSchool grades. The quiz will be 1 point for attendance purposes. The homework assignment will be just a regular 5-point homework assignment in PowerSchool. So thanks for watching. Have a great afternoon. Enjoy your weekend as well.